Hello guys, my name is Desmond. A very warm welcome to my lesson for today, where we will be looking at mathematics. So ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very much important, because what I'm about to say, it's massively. Jeremiah 29, verse 11, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, Sophie, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very much important, ladies and gentlemen, over there. So, most importantly, Sophie Ntau, please remain muted, honorable member. Otherwise, we will get disturbed by the background noise. So, click on a button which says mute. So, trigonometry is what we will be doing in today's lesson. So, I'm preparing you to this type of questions. I'm pretty much sure that you guys have started with trigonometry. Most of you guys did indicate how far you've gone and where you are at your schools. So this type of problems is what I'll be preparing you in today's introduction. So just remember that whatever that we will be doing, it's actually to get to that point. So now let's do a very quick revision. If you guys remember, yesterday we did talk about right-angled triangle. I won't re-explain that. So most importantly, we spoke about the cast diagram, which will actually form a part of today's lesson. Remember the cast diagram, we said we're having C there, A there, S there, T there, meaning in this quadrant cos positive, all positive sign, that positive. Okay, so that will form part of today's lesson. But most importantly, to continue from where we left off yesterday, we are going to start off with discussing what is called a reduction formulae. So this is where we are now going to start with our lesson for today. So for the last time, Nomvula, can you confirm if everything is clear, honorable member, before I go deep? Can you clearly hear me?
Yes, sir. Everything is clear.
Okay. 100%. So, reduction formulae. Remember, guys, on a Cartesian plane, which we refer to that as the cast diagram, because of us having C there, A there, S, and then T there. This is what makes it a cast diagram. So if you remember, we said all the angles falling in the first quadrant are called acute angles. Maybe let me write it, because in most cases we're going to refer to this. We call those, okay, I'm just thinking if I should draw this on a separate, yeah, maybe let me draw it on a separate board. You will later understand the importance of this thing. So let me do this and say this is what we call a cast diagram, where we say this is C, this is A, S here, and then we are having T there. Most importantly, we are saying all the angles falling in the first quadrant are called acute angles. You will understand why I'm doing all of this. Obtuse angles. And then here we are having reflex. And I'm sure that you guys do have something similar to this. So you can also pull it out. This is revolution. What else are we having? So that means here we are having angle 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Where we say it is cos which is positive in this quadrant, it is all of the trig ratios positive in the first quadrant, sine positive there, tan positive in that quadrant. So this is the only thing that you need in order to work out those type of problems that I've indicated. But most importantly, guys, in the first quadrant, you have angles which are between 0 and 90. Those are what we call acute angles. Obtuse, reflex, revolution. Let's leave it there for now. Then I'm going to start talking about what we call reduction formula. This is where I want you guys to understand what they taught you in class. What do we use reduction formulae for? Anyone who can guess or explain, what did they say to you regarding reduction formulae before I assume that you are completely blank? What we use those for, or how do we apply reduction formulae, or what are those? Anyone who would like to guess or explain according to your understanding?
So can you please repeat your question?
So it's more like, what can you say about reduction formulae? What do you understand about that? If you've got an example, you can give an example, but just an explanation according to your understanding. Okay. I'm going to make an assumption that everyone is blank. Then I will make sure to go step by step so that we are all on the same page. Listen very carefully. Reduction formulae are used to reduce. Note this one down. To reduce trigonometric ratio of any angle to the trigonometric ratio of an acute angle. So in short, let's say to reduce bigger angles. We talk about angles which are greater than 90 degrees to smaller angles. We talk about angles which are less than 90 degrees, namely acute angles. Maybe let me write it in full. Acute angles. I'm telling you guys, you can see what I'm writing there, but it doesn't really make sense. Now, let's try to make sure that it makes sense to everyone. So, anyone who would like to participate, let me know. Let's say you are having an angle which is 120 degrees. This angle, what is the name of that angle? Is it acute? Is it obtuse? Reflex angle or revolution? What is the name of that angle?
It's an obtuse angle, sir.
100%. So this angle, is it bigger than 90? Yes. So that means we need to reduce it. We reduce it to what? To an angle which is less than 90, which is what? Which is an acute angle. So it's more like we use reduction formulae to reduce bigger angles. Maybe let me make an example so that it makes sense. Because once you understand this part, I'm telling you, you will find it easy working with all of this and you will fully understand all that I'm going to be explaining. So I won't continue until everyone understands this, because if we continue and you don't understand this, you might not fully understand everything that we'll be doing. So I'm well aware that you know how to solve certain problems, but you might not understand what you are doing. Let's say, for example, if you are given cos of, let's say, a 345 degrees. This is the angle that I'm talking about. This angle, what is the name of this angle? Is it acute, obtuse, reflex, or a revolution? When you answer this question, say, for example, it's obtuse. And when I say why, say it's because it falls between 90 degrees and 180 degrees, or it falls within quadrant number 2. That's how you can answer that question. So what is the name of this angle? That is my first question. What is the name of this angle?
Revolution.
Okay, revolution. Why?
Because it falls under quadrant 4,
100%.
270 to 360.
100%. So it's more like to me, under trigonometry, we don't want to be dealing with bigger angles which are bigger than 90. We always want to reduce them to acute angles. So that is why we use reduction formula. Okay, here comes the question, the Chumis. Now that you know this angle falls in the fourth quadrant, when I say, do we need to reduce it? You are going to say yes. And when I say why, you say it's because either yebo. Mm-hmm.
You are cutting on my eye.
Let me quickly check. Jeremiah, am I cutting from your side, honorable member?
No,
Leslie,
sir. Clear.
Chumi, am I cutting?
No, sir.
Okay. Nomvula, you can quickly leave and rejoin. It could be network from your side. So let's see. Chumi, let's continue. Maybe you and I let's discuss, and everyone else will just be watching Chiefs versus Pirates. So unmute your mic, honorable member. Let's talk. This angle, you say it's a revolution because it falls in the first quadrant. Here comes the question: Do we need to reduce it? Yes or no?
Yes, sir.
Why do we need to reduce that angle?
To make it a smaller angle.
Yes, to make it an acute angle. Name. Or
Yes, sir.
we need to reduce it because it's bigger than 90 degrees. So can you see? That's where the reduction formula comes in. Okay, here comes a question, the Chumis. Let's say you are having sine of 13 degrees. You tell me, what is the name of that angle?
Acute angle.
Okay, now, do we need to reduce it?
No, sir.
Why?
Because it falls under an acute angles. 90.
100%. Because it's already an acute angle, therefore we don't need to reduce it. So that means we only reduce angles which are not acute angle. Akanya, does it make sense, honorable member? Sophie, does it make sense?
Yes, it does.
Maybe let me try it with
Yes, sir, it makes sense, but I'm struggling with the metrics.
Okay, Mwana Major, are you still there, honorable member? Can we talk? Re ka ipolela ngwana wa Meja.
I can understand.
Oh, I understand. Okay, 100%. So now, because you guys fully understand, why do we use reduction formula? Now, that's when we can talk about the reduction formula themselves. Obviously, they taught you guys all of those in class. But if you understood what I've just said, we will confidently continue. But let's just keep it simple and not confuse each other. I will focus on reduction formulae using that line. I'm not sure if you guys still remember this line being called, I think they call it supplementary angles. Can someone just confirm for me? And then this one is complementary. Can someone just confirm for me that part? Is that what you also know?
Which angles, sir?
So angles along that line, and then we also have angles along that vertical line. But for now, don't worry that much about that. I will include it when it's necessary. But for now, obviously, all the angles that fall in the second quadrant, all the angles falling in the second quadrant, it's going to be this minus whatever the angle is. So that means you are having a 180 degrees minus, let's use angle theta. This is a reduction formula. So this minus, it actually takes you back to the second quadrant. If you now want to go to the next quadrant, obviously that's when it's going to be 180 plus an angle. And then here we are having 360 degrees to take you back to this quadrant. That's why you minus that angle theta there. Can you see? These are the reduction formula based on angles along that line, which I say it's supplementary that. We also have reduction formula using that vertical line. That is why now your teacher might say, you're going to say 90 plus, it takes you to the second quadrant also. So that means in the second quadrant, if you say 90 degrees plus whatever angles, it takes you into the second quadrant. But you can see, if you say minus, it's a reverse. It's more like you're saying 90 degrees minus an angle. It takes you back to an acute angle. And then with regards to 270, you can see reverse means minus. So that means if you say 270 degrees and you minus an angle, it takes you back into this quadrant. But if you say to the next quadrant, it's more like you're saying 270 degrees plus an angle. So in most cases, I would always advise you, where possible, to use the angles along this line because they are not that much complicated. But the moment you use angles along this line, remember, it's 270 and 90. Angles along this line is 180 and 360. So now I'm going to ask you guys a very important question, of which if you can fully answer or understand when I explain, then it might be a bit better for to understand going forward. But before I ask my question, did you guys understand when I explained this reduction formula in terms of why we are having this in that quadrant, that there, that there, that there? Does it make sense to everyone?
Yes, sir.
Yes, sir.
Okay, 100%. Here comes the question. Now, this theta, what is the name of that angle? Okay, there's a question. Yes, honorable member. What is the question?
Only possibility of more the acute angle 360 plus theta O.
Okay, makes sense. So a very good question asked there. Honorable member is asking if we can possibly have 360 degrees plus an angle. So at this stage, for this one, I will include it at a later stage. But this one of 360 plus, you always don't know whether this one, let's say you do know, but 360 plus an angle, it doesn't mean it falls it doesn't mean automatically it falls in the first quadrant, second quadrant, third, or still fourth. There is a possibility of having something similar to this might happen. But for now, I just want to say it doesn't mean it falls in this quadrant, that, or that, or that. It will depend on whatever the value that you'll be having. For example, let's maybe say 930 degrees. Yeah. Can you see 930 degrees is greater than 360? So that means it's going to be a 360 degrees plus whatever angle. What will that angle be? Maybe let's see. Just say 360. Hey, let's try this malam. Okay, uvukile. 360 minus 930. So that means if you plus that by 570. So can you see? It's actually 360 plus an addition of 500 and something. So that means after 360, it still has to rotate by that angle of 500 and whatever. So it can land here, it can land here, it can still pass again. So for now, honorable member, we just keep it simple, but I will get to this one, Matapelo. I'm not sure, Matapelo, if you get what I'm trying to explain there. Okay, so this is the question that I was about to ask. I was saying this angle theta, what is the name of that angle? Is it acute? Is it obtuse? Is it reflex? Is it revolution? So every time when I say the name of the angle, I'm simply referring to those four names: acute, obtuse, reflex, or that.
Acute angle.
To me, acute angle, nay.
Yes, sir.
100%. 100%. So that means the moment you use this reduction formula, always know that this theta is an acute angle. I'm not sure that you miss. Do you want to tell what does it mean when we say it's an acute angle? What can you say about that?
That it's a number that should be smaller than 90.
100%. So just say a number between 0 degrees and 90 degrees. So obviously you use a reduction formula to reduce it to an acute angle. With you guys understanding that part, I will confidently move on to the next part of today's lesson, where we quickly try to work out some exercises and see if we can be on the same page. Because once you fully understand that, I'm telling you guys, the only thing that you guys might struggle with is to work these problems by using your mathematical knowledge. So I will straight away start with those because I'm well aware that you have done those at school. But let's maybe start with the smaller ones. Maybe to save time, let me explain what happens there. Then, when we get to complicated questions, when I explain and you don't understand, let me know. So myself, this is all that I need. I just need to do that. And I say CAST. That's all that I need. Every time when I'm dealing with this type of problems. Here comes a question. This thing, is it an equation or is it an expression? So every time when you see an equal sign, just know you are dealing with an equation. If there is no equal sign, then it means it's an expression. This is an equation. This is an expression. When you have an equation, you solve. But when you have an expression, you simplify. So since I'm saying this thing, it's an expression because I don't see an equal sign, that means I need to simplify. So that means this thing, examiner assumes it to be complicated. Then you need to simplify it, meaning you need to write it in its simplest form. And what I like about simplify is that you can always prove if your final answer is wrong or correct. So now, this is what happens. You see you are having trig ratio of cos. But now 180 plus angle, it takes you in which quadrant? In the third quadrant. In the third quadrant is cos positive or negative? Is negative. So that is why I'm going to have negative cos of an acute angle over, you do the same in reverse. 180 minus that takes me to which quadrant? To the second quadrant. In the second quadrant is cos, negative or positive, it's negative. That means you are having negative cos of an angle. Then you can see that cancels, you just remain with 1. So how do you prove if your final answer is correct? So where you see angle theta, one can substitute 30 degrees, if you like, maybe 60 degrees. So substitute 30 there, punch and check if you get 1. If you do, then we move on to the next question. So if you use 30 there, here you must use 30. If you use 60, here you must use 60. Where you see angle, you use the same angle. Where you see theta, does it give you 1 when you substitute?
Yes, sir, it's equals to 1. So I want to
100%.
ask
That
something.
means, okay.
Are we not supposed to use 45 degrees?
For what purpose, honorable member?
Because I heard you saying that we must use 30 and 60. Since 45 is an acute angle, so are we not supposed to use it?
Oh, okay. No, it makes sense. Okay, it makes sense. So it's more like the chumis. Let me quickly rewrite that. Cos of 180 degrees plus that. Cos of 180 degrees minus that. So just to clear that, the chumis, when I say use 30 or 60, you can still use 45. You can use any number. This is for us just to prove if our steps are correct. This one has got nothing to do with anything else. Maybe let's try 220 and see if it's going to work. Substitute 220 there and 220 there. We just want to see if our final answer is going to end up being 1. So it's more like, solve for Xmos. Somehow you can prove if your final answer is correct. So this is how you prove when you simplify. Maybe let me try it from my side and see. Then we'll make a conclusion on. But do you understand what I'm saying, the chumis?
Yes, sir.
Yeah, so this is just for the purpose of us trying to prove. Can you see, with 220 it gives us 1. Even if you use 1, let's see if you use 1. What matters the most is that where you see angle, you must use the same value. You see, even if you use 1, whatever number that you substitute there, you need to get the same as the final answer. So for me to say 30, 60, 45, or whatever, it's because after I realized whether you use any number, you will still get the same number. So for me, I used the special angle. Special angle, there's one for 30. So if you want to be like me, don't stress about any other values. Just use 30 just to prove, only to prove. So if you substitute 30 there, 30 there, then it doesn't give you the same as the final answer. Then you might have made a mistake somewhere. Before you move on to the next question, then you quickly try to rectify that. Maybe let's try the second one and see. Let's see. We are now having, remember guys, these are just easy. These are just easy stuff. We will get to some complicated stuff as time goes on. So just make sure that I don't leave you behind, because but this chapter or this part of trick, it's not that much complicated. You can only make some small mistakes which might cost you some marks. Okay, let me also explain this one. Is this an equation or an expression? It's an expression. What does it mean? It means you simplify. Okay, let's now start. In reverse, 180 plus, it takes me in the third quadrant. And in the third quadrant, this thing is the one which is positive. So that is why I'm going to say tan of an acute angle. So can you see the chumis? It's already reduced. I'm done. Now I'm going to reduce the next one. Let's reduce it. 360 minus, it takes me into the fourth quadrant. And in the fourth quadrant, it is negative. Sign is negative. Most importantly, inside the brackets, write it as negative sign acute angle. The mistake that you make is not to write it inside the brackets. Then when they say 3 minutes left, you are now rushing. Then you forget this is a negative and you take it as a minus. And that's where it dribbles. So 360 minus angle, it takes me there. Tan is negative there because it's only cos which is a positive there. So that means I'm having negative tan of an angle. So can you guys see? Negative cancels with negative, tan cancels with tan. I'm only remaining with sine of an acute angle. So chumi the chumis, the reason why it ends there is because you can no longer further simplify it. Why? Because already it's as an acute angle. Does it make sense, the chumis, why it ends there and you cannot further work it out?
No, sir. And why did you put that positive on the second step of tan?
Was it cancelling or was I putting a positive? So just remember that part. It's not positive. Is this negative cancelling that negative? It looks like positive.
Oh, okay, sir. Okay, sir.
100%.
So, is it possible
So,
that we cancel? Is it possible that we cancel those negatives even if the trig ratios are not the same?
100%. You know why? It's because this thing is actually positive 1 times tan angle multiplying negative 1 times sine angle over negative invisible 1 tan angle. So the negative, you see the trig ratios are not the same. This negative is not for sine, but it's for that invisible 1 there. So it's more like it's actually negative 1 cancelling negative 1, and you just remain with sine tan. And then now you are having that tan cancelling with that tan. So you are remaining with positive invisible 1 and sine. So that is why finally you have that positive invisible 1, and it's multiplying that sine angle, which is the same as just sine angle. Does it now make sense that you miss? You remember, during our first lessons, we said when you're having x plus 2 is equals to 0, some of honorable members, they are seeing a positive invisible 1 there and a positive invisible 1 as a power there. I'm not sure if you guys remember, but does it make sense what I'm explaining there?
Yes, sir.
Okay, 100%. How do we prove this one now? Be like me and use 30. Let's see if it gives you the same answer as when you put 30 there. Does it give the same answer? Luyanda? Does it give the same answer?
Sine theta, yes.
Okay, last one to confirm. Jeremiah, does it give the same answer on your side, honorable member?
Yes, sir, it does.
Okay, 100%. So very quickly, let's move on to this type of a problem. So I'm telling you guys, you are not having a challenge with working out this type of problems. The only problem that you guys are having is to interpret the given problem and follow mathematical procedure. So now, this is how you work it out. Here comes a question. What is this? Is it an equation or is it an expression? If you don't see an equal sign, it means it's an expression. If you don't see an equal sign. So since it's an expression, what do? That means you simplify. You only solve if it's an equation. So simplify means examiner assumes this to be complicated or long, and they want you to write it in its simplest form. Where do you start? At all the times when you are dealing with mathematics, where there are brackets, just remember a say which says, where there is smoke, there is fire. Where there are brackets, there is fire. So that's where you start every time when you have a maths problems. So that means, one, you can write it as it is because there is no smoke there. But most importantly, now with this having a squared there, that's where most of you guys are failing to interpret that. This is what it means, Bantubagiti. This squared, maybe let me explain it this way. If you are having sine squared 30 degrees, they had to have a very long meeting to discuss how to actually present this. And this is the suitable way. Imagine if this thing was written as sine 30 degrees and then they use a squared there. Can you see? It wasn't going to make a sense, Bantubakiti. So it was better for this thing to be written as that. But what you should at all the times remember is that the moment you want to write it in the simplest form, you say sine 30 degrees and then you write that squared to the outside. So that means this one, it's going to be minus, because you already have an angle that you need to reduce. I'm going to use this bracket of the corners because I know inside I'm going to have the brackets. So I'm going to say tan of 360 degrees minus an angle. Then I do that one, then I square. Chumi the chumis, why did I have to rewrite it in that format? It's so that I can easily or nicely reduce that. Someone can say, I can do it differently, or I can write it differently. So someone can still say, since I know 2 means 2 of the same thing, that means it's actually tan of 360 degrees minus an angle multiplying tan of 360 degrees minus an angle. The only difference between these 2 steps is that here you will reduce this one and still reduce that, but the same reduction is the same because it's 2 of the same thing. With this one, you just reduce it once, then you rewrite it in that format. Maybe let me continue from there to say, if you did it this way, then you are going to say 1 minus, when you reduce this, 360 minus takes you in which quadrant? 4th quadrant. Is tan positive one? It's negative in the 4th. So that means you're going to have negative there, and then you say tan of an angle. Now can you see? You need to remove the brackets. That is where you say this negative times that negative, it becomes a positive. So that means finally you are having a, but wait, I just remembered something now, which makes it even more dangerous. And I hope you guys will notice something out of this. Do you guys notice that I forgot to write that negative there?
Yes,
No,
sir.
that power of 2 there. That's what I meant to say. So now, if I write the power of 2 there, it now changes the game. You no longer have that. Why? Because this squared, it actually removes that negative there. Because you have an invisible one there. So this squared, it squares that one and it also squares that. So that means from this, you are having 1, still that minus, and then this one ends up being positive, then it's positive tan. And no longer this. So in short, it means try to practice some more and allow yourself to make this type of mistakes so that you won't make them in exam. Imagine if I was rushing and I did it that way. I wasn't going to remember that. And the reason why I remembered is because I know there are multiple ways to work out that. And I noticed from this one that it wasn't actually going to end up having a positive there. Maybe let me try the second method, and then from there I will accept questions. So that means if you do it this way, you still have your 1 minus 360 minus in that quadrant tan negative. Then because it's negative, you put it inside the brackets. Then because you had 2 of the same thing, you just write the same thing there. Then it means you have 1 minus being that minus. So you now have negative 1 multiplying negative 1, it gives you positive. Then you have tan multiplying tan, then it ends up being tan squared an angle. I think this method, it makes it a bit easier with less mistakes as compared to that. But you can still apply this one. It also makes it easier and quicker. Maybe let me allow some questions. Anyone who's got a question in relation to what I've done there?
Can you repeat more steps I want? Step number 4.
Let's say a 1, 2, this one.
Sir.
Okay, so on that one, you are having this one and that minus there. So it's more like you're multiplying that by that. So can you see? It's negative multiplying negative. It gives you positive. It's a tan angle multiplying tan angle. So it's more like you are having tan angle squared. But you know, mathematically, you can't write it in this format, is wrong. So that 2, you don't put it there, but you put it there. So can you see? Now it's more like you're having 1 minus obviously invisible 1 there, multiplying this thing inside the brackets. You end up having 1 minus tan squared an angle. I'm not sure if I want to know ngwana Mametje.
Say, well.
Okay, 100%. So let me see if I can find another one that we can work out. Let me try find something a bit more either interesting or complicated, even though it might not be. So let's write down this one and try to work it out. Also, you guys try to work it out on your side. I just want something. Okay, let's maybe start with this one. Tan 360 degrees minus an angle. So remember, guys, these are just problems coming from a study guide and not exam question paper. So everything inside a study guide should be easy. It only gets complicated during exam. But I know the moment you start having signs of a plus or a minus in between, that's where you guys start tatazeli. Now I want to see if you're going to survive. Okay. Anyone who would like to give it a try this one, or would you like for me to explain it? Or do you think you can work it out? Even if you can't finish it till the end, can you at least do something on that one? Anyone would like to give it a try? Wherever you end, someone will continue.
I would like to give it a try, sir.
Okay, give it a try, the Chumis.
Tan 360 minus theta, it's minus the tan theta. And cos 180 plus theta.
The Chumis, I was
Yes,
about to
sir.
say, mathematically, we have a minus and a negative. Name.
Yes, sir.
Yeah, so this is 2 minus 1 is equals to 1. But this is negative 2 minus 1 is equals to negative 3. So that means this is negative tan angle. Mathematically, ne?
Yes, sir.
Yes, just so that we don't forget that we are having a negative and not a minus. Okay, let's continue, honorable member.
Cos theta 180 plus theta, it's equals to negative cos of theta, because cos is positive only at the first quadrant and fourth.
100%. So can you see, because you said negative, that's why I'm putting it inside the brackets. If you said minus, I was going to write that big minus. Okay, continue, honorable member of the opposition party.
Cos 360 minus theta is equals to cos theta, because cos is positive on the fourth quadrant.
So can you see, because it's positive, I'm not putting it inside the brackets. Continue, honorable member of the opposition party.
Minus
100%.
cos 180 plus theta is on the second quadrant, and cos is negative on the second quadrant. So we are going to have a negative cos of theta.
Wait, Chumi the Chumis, can you repeat that one, honorable member? I heard you saying second quadrant. Are you sure?
It's negative on the second quadrant, sir.
Okay, let's start it. This angle falls in which quadrant? You say second.
Oh, sorry, sir. Third quadrant.
Yes, okay. In the third quadrant, what happens to cos?
Cos is negative.
So that means I'm going to write it as what?
Open brackets
Mm-hmm.
minus cos of theta. Oh, negative cos of theta.
Hey, I almost dialed 10,111. You are lucky, honorable member. Okay, let's continue.
Negative tan of theta, we're going to change it to be negative sine of theta over cos of theta. Negative.
Okay. Then, the Chumis, let me give you maybe some advice when it comes to that one, and say,
Yes,
just
sir.
to remove the confusion. You remember you have invisible one there, isn't it?
Yes, sir.
Yeah, so before you can do anything else, if you can somehow work out the negatives, let's work them out. So this thing is like you say -1 times -1. It ends up giving you positive tan that multiplying positive cos x over. Then this one is cos of an angle. Can you see this is -1 multiplying that -1, which gives you positive cos angle. The reason why I'm saying do this, the Chumis, before you can expand that, is because I'm not sure if you remember me saying where there's smoke, there's fire. Do you still remember me saying that, the Chumis?
Yes, sir.
So that means you need to firstly dimmer the smoke. I'm not sure if you get me on that one, honorable member. So can you see? Now we no longer have the smoke. Why one?
Yes, sir.
100%. So, if you approach it that way, then it's going to be easy. You will see all the honorable members, they will agree with your motion of no confidence. Let's see. What are you saying now, Chumi the Chumza?
Sir, so is it wrong to expand that tan theta?
No, it's not wrong. It is not wrong at all. So you can continue the Chumis.
Okay, sir. So, sir, I want to expand that tan of theta.
Mm-hmm.
It's going to be sine of theta over cos of theta.
Yes, so that means always tan is always sine or over cos of an angle. Okay?
Multiply by cos of theta.
Mm-hmm.
All over cos of theta
Mm-hmm.
plus cos of theta.
Mm-hmm.
And then I remove that cos of theta because with the cos of theta under a sine of theta because there is a multiplication there.
So they cancel like that. Nee.
Yes, sir.
Okay, then you are having this. Okay.
Yes, sir.
Then it's done.
No.
Mm-hmm. Continue.
And then it will be sine of theta over 2 cos theta.
2 cos theta. Mm-hmm.
Then it will be equals to 2 tan of theta. Is it wrong, sir?
2 tan of theta. Hey, Chumi the Chumis, imagine you being in exam and you end up having that final answer. Are you going to call Minister Angelina Msera and say, I'm not sure, is it wrong? Are you going to call her the Chumis?
No, sir.
So this is where you now use that 30. Do you remember this 30?
Yes, sir.
Okay, now everyone use that 30 and tell me if this is wrong or correct. Let's see. I'll just be waiting. Me, I'm eating, guys. Today I'm eating crocodile. I'm not sure if you guys eat crocodile, but if you want, I can share. But in the meantime, Chumi is asking, is that wrong or correct? Me, I don't know. But this can tell. Whoever gets the answer, please let me know. Maybe let me also work it from my side. Let's see. Remember, guys, if you've got any question, let me know and I will explain. I know someone is done and they're just waiting for others to say something. What are you guys getting there? Guys, what are you getting there?
Two square root of 3 over 3.
When you punch which one?
Tan theta.
When you punch this one, you are getting 2 square root of 3 over 3. But when you are punching on that one, do you get this? Guys, I will need your participation on this one because that's how I will understand if you guys are struggling or not. But imagine if you don't participate and someone gets it correct. I'm going to think that everyone got it correctly. What are you guys getting when you punch there using that angle of 30 where you see theta? Matapelo, ke tse wena tse tša o puncha o di rata kudu mna. O rara se o e punchela, ke a tswa re o e punchile mara o sure. O kry-ile?
I'm getting square root of 3 over 6.
Square root of over 6. Different answer. Okay. What are you guys getting there? Who else got an answer for that one?
I got 2 square root 3 over 3. 2 times 30.
Okay, but hey, you guys, kurle li khateleje kae? O ka re la itshaba. Hey, Jeremiah, why is it like you're watching Gomorrah there? Jeremiah 29 verse 11. Leslie them are Leslie's. Alco is on the line. Luyanda is there. Sophie, are you? Hey, Lindywe is there. Lindywe, How Bosisiwe? You're also here on. Okay, maybe let me punch it myself and see. I'm going to start with a fraction button. Then I say tan 360 I minus an angle being 30. Then you multiply by cos 180. You plus 30, you close. You go to the bottom, you say cos 360 minus angle being 30. Then you minus. You say cos 180 plus angle being 30. Then you say it's equals to. You see, this one, it gives me a square root of 3 over 6. So, Chimidechumis, you tell me, what does it mean when you don't have the same answers? What does it mean? Okay. The chumis, let me also try it myself and see how far I'm going to go with that one. But you were on the right track, honorable member. Let me also give it a try and see. So I'm going to say this takes me to that quadrant, and in that quadrant, tan is negative. Multiplied by this one in which quadrant? In the third, and in the third, cos is negative. This one, what am I having there? I'm having this in this quadrant and it's positive there. Minus being that minus. Here I'm having cos of that. This takes me in the third, and in the third cos is negative. So I'm having negative cos of an angle. So it is at this stage where I'm going to say that negative, I cancel it with that negative. This one, it multiplies with that. So you end up having tan of an angle multiplying cos of an angle. The whole of that is now dividing cos of an angle. Obviously, it's a plus because those multiplied, and then cos of an angle. There are multiple ways in which you can work out this one, honorable member. Maybe let's see. I think you were right, of course, in saying you end up having, let's say, tan that, cos of that. Before you work out this one, let's maybe add those two. So that means we are actually having 2 cos of an angle there. So can you see what happens, honorable member? It seems like that cancels with that. And by the look of things, it's like you end up having tan angle which is divided by 2. So let's now try to punch that one and see if it's going to give us that one there. When you punch this one, does it give you this? If it doesn't, then it means this is wrong. But if it does, then it means it's correct. Remember, we used angle 30 to prove, to get that. So use that same angle there. Maybe let me punch it because, hey, you guys, let's see, tan
No, it's the same.
It's right,
30.
sir.
Oh, yes. Okay. So, most importantly, the chumis, when I was in high school, if I get every problem correct, I don't get too excited. It only excites me when I do things incorrectly because that's how you learn. And this is how you're going to
Yes,
learn
sir.
the chumis. You tell me, do you notice your mistake and where did you go wrong? Because you were coming nicely,
Yes, sir.
but somewhere, where did you make a mistake?
I made the mistake, sir, by by expanding that term and then cancelling
Yes.
those two courses before I add the
Yes.
courses underneath. Yes, sir.
Yes. Yes. So this is what I would do, the Chumis. After doing many problems, then I would try to make a conclusion to say, okay, where there is fire, no, what am I saying, the Chumis? Where there is smoke, there is fire. So that means always you look for where there are brackets. You see, there are brackets, you work it out. There are brackets, you work. There are brackets, you work it out. Can you see? This is you trying to make a conclusion to say, every time when I'm dealing with this type of problems, where there's smoke, there's fire. That's where you're going to start. Then from there, you can deal with a, let's call them like terms. Yeah, maybe let's say like terms. By like terms, the Chumis, you are simply saying, if you have cos and cos, then work them out together. It doesn't matter whether you have 2 cos there, 3 cos there, but because they are the like terms, you work them together. And then lastly, this is where now you can expand those that are expandable. Expand. Then in brackets, I would say tan, just to remind me. It's not only tan that you can expand, even 1, you can expand it, and some more, but we will get to there. For now, we are just doing the basics. Imagine if I assumed that you guys were taught all of this in school, and I don't take you through this, you were going to have a challenge because there's always a starting point. A, a child or a baby who's still crawling, you can't expect them to run without them having to learn how to walk. So we need to go through this type of a lesson, which may look like an easy lesson or a boring lesson. But I'm telling you, it's not about you knowing how to reduce that angle and everything. But you need to understand that when you have a sign of a plus or a minus, you need to work it out differently. I can tell you now, Moleboge, if that sign was not there and it was a multiplication there, in less than a second, the Chimis was going to get full marks for that question. So that means the moment you start having a sign of a plus or a minus, whether at the bottom or at the top, just know your problems are now starting. It's easier when you don't have those signs, but when they are there, just know that it's always a bit tricky. Maybe let's try the last one. I so wish the Chumis, you can still give it a try because I notice you are onto something, honorable member. Maybe let's say this one. Someone different who would like to give it a try. This one. It's not complicated. It's not really complicated. So, the Chumis, did you see that list that I wrote there? Every time when I deal with this type of questions, I always have that list next to me. So that means when I do something different, I check if I need to update that list. Then throughout the year, if you do all the questions referring to that list and it doesn't change, then that's when you can stick it to your head, knowingly that in exam with a pencil, when it comes to this type of questions, you can just write it down because it's going to remind you. Just like that one. You just always have that, then it's easier to remember. Anyone would like to give it a try, that one? Or is it complicated? Remember, If it's complicated, let me know so that I will explain it. Hey, Jeremiah, ithini verse ntombo?
Okay, so I think it's gonna be negative sine squared theta, as sine lies in the fourth quadrant and it's negative there. And then over sine theta times negative sine theta, because it's negative in the third quadrant. Yeah, after that I'm lost.
Hey, kanjalo nje. So
Sir,
you see,
can I give it
Jeremiah.
a clue?
Okay. No. Maybe let me make Jeremiah just like you did the Chumis. Let me do with Jeremiah. Want to see how far we can go. Jeremiah, are you still there? Can you unmute your mic, honorable member?
Yes, sir.
You remember, Mos, we said where there's smoke, there's fire. I'm not saying this is correct. I'm just guiding you. You remember, Mos? So that means you need to start where?
With the brackets.
Okay. Now you are in the right direction. So what do you do with the brackets? Because you can see they are there. How do you remove the brackets? So this thing, it's like 2 into 4. No, 2 into negative 4. How would you remove the brackets for 2 into negative 4? You see
So
this by that.
you're cutting.
Okay, maybe let me explain it, but at the same time working it out. Unless if the Chumis is able to hear me, then we can continue. The Chumis, maybe let's give it a try if you can hear me.
Yes, sir.
Jeremiah was having some network problems, but maybe let's try it on our side. I noticed something with Jeremiah's question. I hope you will notice it, then we'll make a conclusion. Okay, the Chumis, let's give it a try.
So it's going to be a negative sine squared theta. All over sine theta. Multiply by negative sine theta. Then we put the brackets on negative sine squared theta. All over sine theta.
So you
Multiply
can
by
just continue. I'll write. You don't need to take the pause. Just continue. Then I will write.
yes, sir. Brackets negative sine theta. And then we cancel negative sine squared theta and negative sine squared theta. Then we will going to have sine squared theta over sine. No, it's going to be sine theta. Over sine theta. Then it's going to be 1.
Mm-hmm.
It ends there,
Helele.
sir. Yes, sir.
Okay. Hey, I think this one I'll need to also work it out from my side. I'm sure you guys wrote that thing. Kana, what did I say, honorable member? I said where there's smoke, there's fire. What was next? Did you guys not write that? What was next? Guys, you didn't write this list.
Like terms.
Okay, like terms, yes, now I remember. Like terms, and then here it was expand, ne?
Expand.
Yes, expand, and then in brackets you said turn. Matapelo, you will understand why it's important to have this type of a thing. Now I'm going to work it out, and this is what I do. Where there's smoke, there's fire. So let's see. Can you see this thing when it's written like this? Remember, this thing it's actually the same as sine 360 degrees minus an angle. That squared, you put it on the outside. And then here, you can just say sine of an angle. This thing, it falls in the third quadrant, and in the third quadrant, that is negative. So you are having negative sine of an angle. So now you reduce this one. When you reduce this one, in which quadrant? Fourth quadrant. This is negative. So that means you have negative sine of an angle. You do that. So when I was asking to say here, because you see where there's smoke, there's fire. This thing is the same. It's more like you're having x minus x, this thing. Don't get confused by sign. So this thing is the same as negative x squared. So that means this one is the same as negative sine squared angle. That's where you get it wrong. So just make sure that you understand it that way. When you see tan, maybe let's say examiner says tan 3 angle multiplying tan squared angle over tan angle. And you don't know how to interpret this. It's more like you can say let tan. In your mind, you don't write it. You just say let tan be equals to y. So this thing, it's more like is y cubed times y. What is that? 5 over, no, this is 2 over y, which is the same as what? That times that, you add the exponent. So it's more like you're having y to the exponent what? That is 5 over y. Obviously, there is invisible 1. So it's more like it's y, 4 minus 1, it is that. Then it's done. So it's more like this thing, if you had to work it out, you might need to check if it ends up taking you where is tan 4 being that 4, whatever. Yeah. So it's more like I'm saying if you try to simplify that, it might end up giving you that. But the principle behind the tan, you can take it as something else. So now this is where you are going to notice a mistake. When you have, since we say we are having sine angle, let's maybe say that sine angle is the same as negative 2. Then we have a squared there. What is into negative 2 close squared? Is it negative 2 or is it 2? What is it?
Can you please repeat the question, sir?
Is it 2?
Into negative 2 closed squared. Is this thing equals to negative 2 or is it equals to 2?
2.
Someone punched it and it gave them 2. What makes it to be 2? Because we have a negative there. Why is it not negative 2? Okay, this is the reason. It's because this squared, it means 2 of the same thing. So it's more like you're multiplying negative 2 by negative 2. Negative times negative is positive. 2 times 2 is what? It's 4. So that means this thing, when you punch it on a calculator, it is not negative 2, it is not a positive 2, but it gives you a positive 4. So just be careful, guys. Just be careful of what the question is and what is the real answer. But this is what I wanted you guys to notice. When you have a squared there, and you're having a negative there, it forces it to be positive. Then this is what you add to your notes to say, when you are having a squared, then the answer results in positive. So it means the mistake that you guys did there, did you guys make a mistake on that one? I'm not sure if you made a mistake. Let's see. I think you did, because you're still having a negative there, whereas it is now supposed to be positive sine squared angle over sine squared angle. And this thing, hey, you did make a mistake, Moss, or did you? Konoshaya manzi la. Yebo.
My answer was -1.
Someone is getting -1. Oh, yes. I'm not lost. I'm not lost. That is because, remember, this one at the bottom, it is the one which is negative. But this one at the top, because of that squared, it forces it to be positive. So that means you're having positive sine squared angle minus sine squared angle. That cancels with that. Then you end up having -1. So between the Chumis and Jeremiah, everything that you have been doing, you were coming nicely. But the only thing that I noticed is that when you have this squared, you actually did not know that it makes or it forces whatever that you are having to be positive. And I can say it's everyone who wasn't aware of that. The reason to that is because you let the honorable member to continue until the end, and again the second honorable member to continue until a certain point, being that point. Everything is fine, but the main concern is that this positive, that squared, it forces whatever that you reduce to be positive. I'm not sure if it makes sense, this part. I'm just not sure. Ntwanambi, did I lose you on that one?
No, sir. I can say my mistake that I didn't put that squared outside the brackets.
Yeah, so can you see the danger of that? It makes everything to be wrong. So that means whether you have cos of angle, I mean sine squared a tan squared, whatever angle that you are having here, it is going to be positive. It doesn't matter whether cos is negative in that quadrant. It doesn't matter whether sine, it doesn't matter. Because of this, it means you are going to have a positive answer. Does it make sense? That's what I mean when I say from this thing, then you just add that on the list. Every time when you practice these questions, you always have that list. Then you refer to that list. In case if you discover something, you add on to that list. That's how you learn. That's how you learn. You can't rely on you grabbing everything in your mind. It's almost impossible to remember everything. But you sort of need to say, when I deal with trigonometry, this is my style of learning. When I deal with whatever, this is okay. Now I'm going to give you guys the code for today, and that will conclude our lesson for today. So I'm not sure. Anyone who's got a question there, or did that make sense to everyone? Next lesson, we are going deeper. Anyone who's got a question, or are we all on the same page?
So I got +1.
Lindy, we got +1. Okay, maybe explain, honorable member. Did you have negative or positive there
I had
for this one?
a negative.
Yeah. But do you know why it's not supposed to be negative, or do you understand why it's not supposed to be negative? Because that's where most of you guys make a mistake.
No, sir.
Okay, maybe let me explain it again this way. A negative sine squared angle. Do you agree that this thing, it actually means two of the same thing? So that means it means two of the same thing. Do you agree with this one, Lindy?
Yes, sir.
So what is negative times negative?
Positive.
What is sine times sine?
Sine squared.
Yay. So that's how it ends up being a positive. So that is why I was saying it doesn't matter whether you have sine squared, tan squared, cos squared. Because of you having this, it means whatever that you reduce, it will end up being positive. Unless if I'm wrong, Bantu Bakit, maybe let's try to prove it. What if I'm wrong? Hey, you see, now I'm worried. Okay, this is how you prove. This is how you prove. Maybe let me remove all of that. Let's try to work it out and see. When you say that, let's see, how are we going to prove this one? Maybe 30 there. Maybe I'm the one who's wrong, Bantu Bakiti. Yeah, maybe this thing, does it give us, because when you punch this thing, I think it's negative sine 30 degrees squared. Yeah, maybe I'm wrong, guys. Let's maybe try to check. Maybe I'm wrong. And remember, guys, just in case if I'm doing something differently, and you notice it's wrong, let's say this is wrong, and you have an explanation of why it is wrong, or you know why it is right for it to be negative, then you explain so that we are all on the same page. I'm getting positive 1/4 when I use 30. But wait, guys. Okay, it's more like I'm saying when I prove it, it ends up being a positive. But I just need someone to quickly confirm for me. According to your understanding, am I wrong or correct?
Correct.
Matapelo says correct. So it's more like I'm saying if you have negative x squared, this thing is the same as negative x, negative x. This squared means two of the same thing. That times that, it gives you positive. That times that, gives you x squared. Again, here's another scenario. You see this x squared, one can argue and say it's not that, but it is negative on the outside, and you have x and you have x. Yeah, I think now I'm going to be able to prove if I'm wrong or correct. I think now I'm going to be able to prove, because now this thing, does it take you back to that? If you say that by that, yes, it takes you back to that. So that means you're having negative x squared. Yeah. Now, let's try to work out that one. Maybe let's try to work out this one. So before, remember, when it comes to this one of having a squared, you can work it out in two ways. So let's try that one. You see sine squared, this thing is the same as sine into 360 degrees minus that times sine of 360 degrees minus that. I'm not sure if you guys agree with me on this one, to say this thing is the same as that. Do you guys agree with me on that one? I think so. Now let's see. This thing falls in which quadrant? It falls in the fourth, and in the fourth, sine is negative. So that means this is actually negative sine angle. This thing also saying negative sine angle. So negative times negative is positive. That times that, it ends up being positive sine squared. Sure. It seems like it is correct.
Yes, it's correct.
It's correct, ne?
Yes.
Hey, because now I was getting worried if I'm doing it the wrong way. Because honorable members are not responsive. Okay, now since someone has confirmed that it is correct, so that means you can now add that to your list. And to always remember that when you are having a squared, it means positive. If you do negative, then it becomes a problem. So this is today's code. You give me an answer to this one. So you just comment an answer to this one. Today, nilebambile. Someone expected to write the letter of their surname. Today, izinto ziyashintsha. Let's see. Sizojika izinto. Sijikile izinto. Okay. It's either you take a screenshot or you write it down, but the code for today's lesson, you just comment with an answer to that one. So that means you will need to somehow work it out, and then from there, comment with whatever answer that you are getting. So it doesn't matter whether it's wrong or correct. Fact that you commented means you attended. So ladies and gentlemen, I am going to run away and say Desmond is my name, and I'm out.